explain to us a bit about V-DAQ and what they do?
Yeah, absolutely. So at V-DAQ, our broader vision is to enable the opportunity that is vehicle data. And right now, there's a very low percentage of vehicles out there that are either semi-autonomous or autonomous or have some form of telematics integration that's transmitting out vehicle data. And the use cases of that is very limited because it's all very closed circuit and not a lot's being actually done with it. So we recognize the opportunity for both a gathering and distribution system for vehicle data that's scalable across all vehicles. So that's kind of like what we've been developing over the last couple of years, and now what we're commercializing and rolling out, particularly into the heavy vehicle space right now in Australia.
Nice, okay, that's really interesting. So you mentioned a bit about telematics, so what exactly is that and why did you decide to go into this field?
Yeah, well, it kind of was a bit of a happenstance. So telematics is generally just the gathering and distribution of vehicle data. Generally, it entails the location, general position of data, as well as things like speed and things like that. But it's very broad. You can go just purely from a tracking perspective, just location, to everything up to multiple sensors, as a speed, like you can do then other outside factors like road surface quality, things like that.
Right. You developed like a new transport tag, I think. So what exactly? How'd you get the idea?
How do you get the idea for the tag? Yeah, well, it started out as a device which would recognize an accident and pass information through to the emergency services, providing more detailed information like how the crash occurred and what occurred throughout the crash so that they can initiate a better response. And that definitely is still part of our platform. We still have that application. But whilst developing the tag or the device that was doing that at the time, we realized how much more we can get into and how much more data and opportunity was available for more applications across multiple marketplaces, just by understanding what's occurring to the vehicle and surroundings, and then being able to distribute that in a timely manner, and as well having accurate data and precise data, because that's a real trouble right now in the telematics space, is having scalable, affordable, and precision data.
Right. You studied a Bachelor of Engineering, right? Yeah. So how did you navigate around the business side of a startup? Do you have something?
Yeah, it was quite interesting. So my business partner Paul and I, we came into iAccelerate and we decided to start the business. It was really taking an idea and learning how to make turn that idea into a business, essentially, or we've now taken it and turned it into a company. So it's quite interesting. I find the business and all the other areas associated with it quite interesting. So you're looking at like the marketing, the legal aspect side of it, and of course like the general broad business. It's very fascinating, and you get to understand more about the customers that you're looking to attract, the market you're entering, and really be able to identify a plan around that. But generally it's all logic. So as an engineer, you learn logic, you can really base that base around that logic.
Okay, that's good, yeah. Started your startup. Were there any things that you didn't expect? Or?
Yes, there was lots of things that we didn't expect.
Yeah.
We've gone through several iterations of our development, each slightly tailored differently to a different portion of the market. And we didn't really expect the path that we would actually end down would be quite so broad, and how much opportunity there was with what we were developing. There's also been times where we've been into rooms with very high-placed individuals and high-placed groups where we've had a lot of input into that, and we've looked around sometimes and said, what are we doing here? But yeah, it's a great experience. Yeah, for sure.
Yeah. So do you have any advice you give to anyone that wants to start a startup?
Yeah, if you love it, do it, for sure. I mean, at uni, it's a great time because in a startup, I mean, as a uni student, you're already used to having not a lot of money, so into a startup, that's not going to change.
Yeah.
Yeah, so it's definitely just an extension of that, I guess. And you're still in the mindset of learning and being able to put the hammer to the grindstone, and really do that kind of work. So it's a startup's a lot of work, and you have to love what you're doing and be have a lot of determination. Yeah.
Would you say there's any like essential characteristics of people that start a startup to be successful?
I think logic and determination be the two. If you have good logic to start with, then generally you can really like account for most situations and identify the correct path forward. And being able to look back on what you've done and recognizing your mistakes, being objective about it, that's really important.
What made you want to start in this area and continue?
Yeah. Well, it started out very, very far back, the original Paces, as kind of like a group project in uni, where the brief was, how can we get our professor to uni faster, throughout the traffic and stuff like that? How can we identify and optimize that route? So one of the items that we came up with was, again, like the crash reconstruction and all that kind of stuff, which would then also be sold to like mapping services and things like that to identify exactly when a crash has occurred, and from that instant map an alternate possible route. Because every second in traffic, I mean, you can imagine in Sydney for sure, when a crash happens, in a couple of seconds you're backed up a couple hundred meters, in a minute you're backed up a couple Ks, So that optimization, having that real-time performance is really, really important. And then from that, Paul and I, we just started engineering our first prototypes, and we, as I said, we recognized the potential, and it was kind of like engineers Candyland with what we were doing, all the different possibilities that we go into, and really, yeah, it's just really fun work. I also have a background I do a surf club, and my dad's a intensive care paramedic. So I do have the background on the emergency side of things, really looking into how we can optimize and reduce the impact of vehicle crashes, both on a death perspective and a serious injury perspective. So that was really interesting for me. And then, yeah, the broader perspective, just all the different opportunities we can go into. It's so many different spaces. And it's not just in the transportation market, but it affects other markets outside that market. It's really interesting.
Yeah. So you started off like it being uni project. So how much of that uni knowledge has been applicable for the business, do you think?
Yeah. Look, as I said before, it's really important having that base perspective from the uni, understanding the fundamentals, and really even just identifying terminology that you could then go and either relearn or look further into, just understanding how to get into things. So that was definitely useful for sure. But there's also a massive amount of like education that we had to do ourselves, self-learning, in developing all this stuff, because it's a little past the undergraduate perspective. We're engineering, and so that's really interesting. We've still been in contact with the university, and we're working with them on several different things, which was really useful, having that connection and being able to utilize some of the resources that they have, which is fantastic. But yeah, there's definitely a good base, but a lot to learn.
Yeah, for sure. There's always lots of learning to do.
Yeah.
Yeah. So how did you like move from it being an idea to an actual business? Like, how do you bridge that gap?
Yeah. Well, it's interesting because I think generally in a startup or successful startups, you'll start with a customer and then work backwards to how to fulfill that customer's needs, essentially, and build it off of that. Where we kind of did it the other way around, where we developed something for multiple customers on a broad perspective, and then really didn't start getting quite specific until the past year or two, really. And that's being good and bad. Is being good because we've built something that's extremely applicable over multiple different sectors and markets, opening us up to a lot of different customers. But it's also been taken a lot longer to get to that stage, to the point where that now we can go out to our customers and say, look, we actually have a product for you, let's do this, and develop and doing it directly for their needs. But then again, that is the advantage of our product, is being able to have that broader platform and infrastructure, and to identify whatever different application needs to go off of it. So, yeah.
And oh yeah, because you started as a uni project. So did you like finish university first and then start, or did it sort of happen in the middle?
No, it did happen in the middle. So that was third year of my mechatronics degree, and third year, and then we started over that summer break. And I was fortunate enough afterwards, and this is something that I definitely recommend to anyone looking into a startup, particularly in engineering, is I was able to do my thesis on it, 2 theses actually, in my final year. And that was really beneficial because I was focusing on the university, but I was also focusing on the company and development at the same time. And that's another reason to why we developed first a lot of our development, our tag, and our product, rather than focusing directly on a specific customer. But that was definitely beneficial doing that.
Yeah, how do you balance uni and running a startup, or like starting a startup at the same time?
Yeah. Well, like I said, fortunately, I was able to do my thesis on the development work I was doing with the company at the time. So that really reduced a lot of that effort, a lot of that strain. I was probably actually here in the office 4 days a week, and the rest at uni, as well as doing my other extracurricular and other activities outside. But I think, yeah, that was the main thing. And for that to occur, I also overloaded a lot in my second and third year at university. And that's one thing I would recommend for any university students going into this space, is try and do as much as you can throughout uni, because you can always do less and kind of skate by, just have a lot of fun and things like that. But the more you do, you realize actually how much you can do. And that really helps when you get out into the workplace, because you recognize, okay, it's no longer just going into toots a couple of days, and doing that kind of stuff. You're actually hammer to the grindstone, working a lot consistently, and particularly if you want to improve yourself and flourish in the industry. Yeah.
Yeah. When you said do more, do you mean do more uni, overload, or try and get as many co-curriculars as possible?
Well, it's either. You can do either, really.
Yeah.
So, because it's all about expanding your knowledge base and expanding your skill set. I definitely could have done that a lot more throughout my first couple of years of uni, for sure. But yeah, it's really just expanding what you know and where you can go. And then that opens you up to understanding more about yourself and more about what you like and more about where you want to go in the future.
Go back in time and tell yourself something. What is anything you'd change, or do you keep everything the same?
Where do I start? I definitely probably would have looked at not quite the perfection that I was trying to achieve at the time. And recognizing more of the functional impact of what we're developing could be applied a little bit more thoroughly throughout for customers. And that probably would have brought in more customers in the early stage, and helped the business grow along that way, for sure.